Hello everyone. In today's class, we will learn uses of dimensional analysis method. Okay, what is that? Uses of dimensional analysis method. Okay, so let's see now what are the uses of this dimensional analysis method. So in that, first one I am taking. Okay, first, that is to check the correctness of the given equation. To check the correctness right, to check the correctness of given equation or physical relation, whatever it is. So let's see how to do this. Now let's take one example. Concentrate and listen carefully how this is. Suppose you are having this relation or formula F is equal to PA by L. PA by L, where F is force, next P is pressure, P is what? Pressure. A is area, and L is length, and L is what? Length. Check whether this relation is dimensionally correct or not. Dimensionally correct or not. Okay, what we have to check, F is equal to PA by L. This relation is dimensionally correct or not. We have to check this. So let's start now. So how to solve this? Concentrate. So given relation is what? Given relation F is equal to PA by L. F is equal to PA by L. Okay, so how to do now? First take left hand side. So LHS. LHS is equal to what? F. Okay, LHS is what? F. So find out dimensions of F. What you are getting? 1 in mass, 1 in length, and -2 in time. You know these dimensions of force. So call this equation number 1. Okay, next, right hand side is what? Right hand side is equal to PA by L. PA by L, where P is what? Pressure. So let's find out first dimensions of this. P is pressure. So therefore P is equal to F by A. Yes or not? And which is equal to dimensions, you will substitute mlt power minus 2 for force, and A is area, so therefore it is L square, and you are getting m, this is 2 when it is going up, minus 2, and this plus 1, L power minus 1 T power minus 2. Next, A is what? Area. Yes or not? A is area. So area is, L square, that is side square. Next, L is what? Length. So L is length, and therefore L dimension is what? Only L. Let's substitute in above equation. That is in from this RHS. Substituting in above equation, we can say. So therefore PA by L, this is your RHS, which is equal to pressure is what? 1 in mass minus 1 in length minus 2 in time. This is pressure. A is area, that is L square, and divided by this L. I am substituting here L. Any doubt? What we did? We have taken LHS, find out dimension or found out dimension. Next, we have taken right hand side. In that, whatever the quantities are there, we have substituted, and then again we have found out dimensions of it. Okay. So let's see now what we are getting. This L will get cancelled with this one L, and 1 plus this minus 1 will get cancelled, or it will get cancelled. Okay. Shall I do one more step? Okay. So this L cancelled with this one L. Now what is left? M L power minus 1 here, right? This is T power minus 2, and here it is L power plus 1. Now this plus 1 and this minus 1 again cancel. So therefore, what you are getting RHS dimensions? RHS is equal to PA by L, which is equal to M into T power minus 2. M into T power minus 2. And call this equation as equation number 2. What is this equation number 2? And here you see this is what? Equation number 1. We will keep this also in a square bracket. Got it? Okay, sir. Understood. Right. Next. Now see, from equation 1 and 2, from equation 1 and 2, is it same? Is it same? No. ML T power minus 2 is here. M T power minus 2 is there. So can I write like this? LHS is not equal to RHS, and therefore given physical relation, that is F is equal to PA by L, is dimensionally incorrect. Dimensionally incorrect. Understand? Got it? Okay. So let's move ahead now. Next example. See here, another example I am taking. Suppose now you are having like this equation. Let's take one kinematical equation. Which one you want? Okay. S is equal to T plus half T square, or V is equal to, okay, anything you take. Let's take this equation. V square, check. v square minus u square is equal to 2as dimensionally correct or not. And given is what? You see, given is what? V is velocity. I will write final velocity. Okay, you know this. V is what here? Final velocity. So V is final velocity. U is initial velocity. Initial velocity. A is acceleration. And S is what? Displacement. S is displacement. This is what given equation they are asking to check it whether it is correct or not. Let's start. Okay, see here. Now what is given? Given is v square minus u square is equal to 2a. Yes. Okay, so let's start from this left hand side. What is left hand side? V square minus u square. So v is what? Velocity. You know velocity is what? Length by time. So this is L by T. Direct I am writing now. You understood? No. Velocity dimension is what? L T. L by T. L T power minus 1 also you can write. So this is square minus here also. This is initial velocity but velocity only. So here also this. So you are getting what? L T power minus 1 whole square minus L T power minus 1 whole square. Sir, will it become 0? No, this is subtraction. Don't cancel like mathematics. 2 minus 2 is 0. No, not like this. Okay. So although you are subtracting velocity from velocity, what you are getting here? Dimensions, that is L square T power minus 2 minus L square T power minus 2. But this is not going to be 0. Keep it in mind. This is very, very important. So dimension is what? L square into T power minus 2. Enough. L square T power minus 2. This is what? Your left hand side. Okay. Don't cancel this like your, what you can say? No, not this. This is because velocity minus velocity is some dimensions of velocity only. This is not mathematics. X minus x is equal to 0. Okay, this is dimensions. So velocity dimensions, if you are subtracting or even we are adding with velocity dimensions or velocity square dimensions, you will get that dimensions only. It is possible only in case of division you can cancel it. Keep it in mind if same is there. Okay, one more time I am repeating, listen. In case of only division, suppose you are getting at numerator same dimension and at denominator same dimensions, you can cancel it. But in case of subtraction or addition, you cannot cancel. Whatever the dimensions you are getting, that dimensions only will be there after subtraction. Got it? Next, this is what your left hand side. Okay, so see now. Next, I will show you that case also. Oh, this is equation number 1, not 2. Just make it here 1. Okay. Right. So this is your equation number 1. Now, let's move to the right hand side. So now what is right hand side? RHS is equal to 2AS. Now this 2 is what rate? 2 is dimensionally constant. 2 is what? Constant. So no need. Okay. So what I will substitute now? This acceleration dimensions L t power minus 2. This is what acceleration dimensions. Into S is what displacement. So this is what only L. So what we are getting here, L square t power minus 2. This is what right hand side. Okay, this is what right hand side. Now see here, equation 1 and 2, what you are getting, equation 1 and 2, what you are getting, are they same? Yes. So therefore, you can write here, what is that? From equation 1 and 2, from equation 1 and 2, LHS is equal to RHS, and therefore given physical equation or relation, whatever you want, you can write. Given equation I am writing, equation is dimensionally correct. Dimensionally correct. Understand? Okay, got it. Next, let's move ahead. Now I am giving one formula. See, next example. Example. Suppose P is equal to G M by R square into I'm taking it as a I, R square into I. P is equal to Gm into R square into Gm by R square into I. Now, what is G, what is Gm, what is R square, what is I, and what is P? So I'm not writing or check this relation, already you know now. Let's check this. So P is what? Pressure. P is pressure. G is universal gas constant. No, let's take this is law of gravitation or constant we will take, not universal gas constant. I will take this as a gravitational constant only. Okay, that is R. Okay, universal gas constant is R. This is gravitational constant. I am taking this as a gravitational constant. Okay. Okay, P finished, G finished. M is mass. M is mass. Next, R is radius. And I is current. This is what given things, and you want to find that is it correct dimensionally or not. Okay. So let's start from LHS. Left hand side is equal to P. P is pressure. So pressure dimensions, you know, M L power minus 1, T power minus 2. Already I have calculated. If you will go back, you will see where it is. I think in this I have calculated. See, ml power minus 1, T power minus 2, right? So you can see that. So let's call this as equation number 1. This is your left hand side. Okay, next. Now right hand side, RHS. Capital G, capital M by R square into I. Okay, so first I will find out dimensions of this G. G is universal gas, G is gravitational constant. So its dimensions are what? Already we have found out, hai na? Yes, can you see in the notebook? Universal gravitational constant or gravitational constant. What is the dimensions? Or what are the minus 1, 3, minus 2? M power minus 1, L power 3, T power minus 2. Again, I am reminding you, please note down the dimension formulae which I have sent you. Next, M is what? Mass. Mass means only mass. Next, R square is radius. Radius is nothing but length, length square. And I is current. So current dimension is what? Only current. So let's substitute. Therefore, Gm by R square into I is equal to M power minus 1, L power 3, T power minus 2. Into this M, this M as it is, divided by R square is what? L square into this I. Now, this is plus 1, this is minus 1. We will cancel this. This L square will get cancelled with this. So here it is 1 power. And therefore you are getting, this is equal to L power 1, T power minus 2. And this is 1 when it is going up. It is I power minus 1. And there is no M term. That's why it is a 0. Yes, so what you are getting RHS now, RHS is equal to Gm by R square into I, which is equal to 0 in mass, 1 in length, minus 2 in time, and minus 1 in current. And let's call this equation number 2. So now is both dimensions are same? No. RHS and LHS? No. So from equation 1 and 2, LHS is not equal to RHS. Yes, so therefore here it is like this. LHS is not equal to RHS, and hence therefore given relation is dimensionally incorrect. Given relation is dimensionally incorrect. Got it now? Understood? Is that clear? Okay. Note down. Okay. So understood? Now I'm sending you some questions. You have to do it yourself. And if you are having time, listen carefully. If you are having time, first you listen the classes which you have missed. And second thing, whatever I have send you table of dimensional formulas, please note down that in the notebook without fail. Keep it in mind. First you note down that, revise, then only it is easy for you, because so many questions are coming for competitive exams from this chapter. So you should be ready and you should understand each and everything. Okay, so first to copy that table. If you have doubt, please call me. Okay, right. So let's stop here for today. Bye.